So let's see what I've been doing. Four commits. Right. Okay, so last work was 4 days ago. Almost finished integrating the game. Remember talking about possibly deleting this boolean? Okay, so now bot takes in the model. Okay, what's the commit message? Almost finished integrating networks. Yeah, I remember that. Right, so I ended off with a bunch of like to-do stuff. I see that like here, we have like the model. Let's see. So we import so this is in the game takes it, and then we load up the model, pass it into bot. In the net, I remember removing that to get it to compile. Because like no GPUs like server side, but like we want to run it like we want to run this like this thing we want to run in the client, right? Actually, maybe this could be maybe we could run this in both actually. Like this thing could be utility that like instead of net.ts like netutils.ts. I remember thinking about that. But like I'm not sure actually. Like when we're compiling this like in run.sh, maybe like if we're doing it server side, we could like import like one or the other. Right. We import cell, right, because we're converting the right here, right? We convert game state to model input, so we like need to understand what cell means. Okay, model. So um I guess this is just indentation because we're in the create model. Um Model.compile, model.save. And then notice that like I mean this commented out. So maybe like one thing to note in mind, I'll just actually write that down right now, like a thought I had is wait, ls good status. Okay, so everything is clean. That's good. V what was the file? Yes. Net.ts, and then create model. Oh wait, no, this is there. To do track if model already exists. Right, to do track if model. So I should actually address that to do at some point. Maybe we'll see. Anyway, so then we create the model. I mean, that's that's pretty straightforward. I mean, it's nice that we have like we use the functional API. Like we kind of take each layer and then we kind of call this function on it. Like we're chaining it basically. Like we're creating a graph where like we have like the value output and then the policy and the value. Like first policy then value. Just like first policy and then value loss functions. Then convert game state to model. And then I was actually thinking like if we go to like bot.ts, like this whole stuff right here, like we're actually extracting the policy, then we're filtering out illegal moves. One thing I think that should be done actually is like, because like remember the whole point of this connect four stuff is to make it like work for BumperCoins and like build a generic, I guess, to kind of build a generic framework for Alpha Zero, right? Like that I can just like kind of swap in. I want to make it as easy as possible, right? Like I want to make it as easy as possible to like to create this for Connect 4 and then just only change the neural network and like some functions and then like boom, it just automatically works for BumperCoins. Like that's the end goal. So I want to kind of think of it from like a like kind of like a framework, like building common library, like making it generalizable, right? Like not just C4 specific. So instead of like doing it here in this like bot.ts, like one thing I was thinking is this whole logic of like kind of like model.predict. I feel like that could actually be moved into the into net.ts here. Like and this convert game state to model input could even be maybe like even a private function, like kind of have a new function that like it's called policy, like right. So like the whole point is that this bot needs a in get move, the spot needs like this prediction should be like we only care about prediction zero. Like we care about the policy, not the prediction one is the evaluation. We just need the policy. So like this whole stuff, including the filtering, could be actually like wrapped into net.ts. So the net.ts, like it's gonna be used like both client side, like when you're running the game or running whatever simulator, like running it like from a browser. But then you also want to use net like presumably a server side too, like when we're actually running Alpha Zero to like I say server side, I mean like when we're training the AI bot, when we're training our neural network, right? Our Monte Carlo tree search, our training episodes, whatever, like so like in fact that's like the whole TF.js no GPU versus that. Like can we do conditional import? This stuff looks too complicated to me, to be honest. But yeah, like my idea was I was thinking I'd have like environmental variable, like whether I'm running it. Actually, no, what am I saying? Um, whatever. This whole no GPU is optional, right? Just to like enable the speed up. Um, hmm, hmm, hmm. Um, I mean, when I'm actually training bots, I don't think I'm gonna do the training in net.ts, right? Will I? Um, hmm. Well, let's not worry about this too much. In worst case, I can really just like duplicate this. Well, yeah, let's not worry about this. Yep. Okay. We'll worry about it when we need to worry about it. Okay, so convert game state to model input. Right. Okay, let's think about it. Like I could actually like 'cause I remember I had some print statement, right? I was like float 32 array. Like I could actually like get it to work in bot.ts and then move it onto net.ts, right? Yeah, no, no, but the whole point is that like I want this all to be transferable to BumperCoins too. So what I can do is I can actually like kind of like look at it in terms of consumption, right? So let's have like export. So let's delete that. Let's just kind of go here, copy that there, go back there, paste it. Um, 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 Something like this, right? And what we can do is um predict or get model get like let's think about it from the perspective of like here, right? This neural network, like the whole point is two outputs, the value and the policy, right? So like let's get policy and value. So we take in the game state, right? The game state knows whose turn it is, and we also have to pass in the current model, right? Which is a what's it called? A layers model. Well, let's just kind of say that there. We net.ts bot.ts because I know bot has the model too, right? Layers model. Okay, so then that's kind of like the idea. What should this return? this does not return a TF tensor. What this should return, right, is it's a pair of two things, right? A policy and a value. I'm just gonna pretend like we have a class called policy for now, and a number, right? So let's actually create a policy class, right? Policy.ts and move.ts for good measure, right? This is our class policy. Okay, so then again, like right here, right? Wait, what? This is net.ts? So right, like you see like line 33, like list of pairs where like pair 0 is the column index and pair 1 is its probability. Like this I'm gonna like kind of like this whole tutor, like these comments I did at the end of last stream, like my idea is that like the filtering everything, like the policy data, like this stuff is going to be like in the policy. Like what is a policy? A policy is a bunch of moves and their probabilities, like a bundle, right? Like there's a bundle of the move probability, right? And then we'll list it. So that's going to be our thing, right? Yeah, okay, that's quite straightforward, is it not? Like we're going to basically have our data, right? Or what's the data? Moves and moves and weights and prob. Should we just Google that? Like, what is a policy? Like, what is a policy then? Probability vector of all possible actions. By possible, we mean legal, more specifically. Moves and probability as probabilities. Let me just Google that. Probability. Oh, I got it correct. Right? Probabilities. Ah. So this is going to be a list of a bundle, right? Something like this, right? Where the first thing is going to be the move itself, and then just a number. Save that. Okay, so this is like the kind of the fundamental, like the raw data. So like policy consists of a list of all the legal moves and their associated probabilities. I just pasted that. Okay, so that's kind of like the idea, right? Note the inclusion of legal. Okay. All right, that is good. That is good. Move. So then we have move. Yes, yes. Move is quite simple. Just the whole point of move is a column index. That's the last file. Policy and bot. Right. So all this stuff here, like we have to kind of copy that there, right? Just create a model for move and using model predict. So now, wait, why did I write that? What is going on? Sorry, I'm pretty confused. Right. Okay, right. So now what I'm going to do, yeah, we have to import this policy, obviously, right? Policy from there. Okay, this looks good. Just make sure everything compiles. Okay, so I have to import move. Let's do that. Oh yes, we have to actually return it. What's the error message? Either undefined must return a value. Okay. Just, I mean, this is a skeleton function. Or actually, let me just actually do it, right? Let me actually do this. So then, how does bot do it again? Oh, what? Sorry about that. Let me just, right? This is net.ts. I'm gonna fill this up. Actually, for now, let's just return something. Just a new policy. Number 0.0. Let's see if that clears the flags. Clears all the errors. Okay, something is wrong. Something is wrong. Oh, I'm missing a bracket. Okay. Okay, good, good, good. So now let's kind of do this again. Go second. And here's a prediction, right? Okay. So now, how do I like do that, right? Float 32 array. I just want to make a regular number array. To number array TypeScript. Array.from. So let me see if policy data is actually what do you call that? Float 32 array, right? I want to see if this compiles. Okay, yes, it works, it works, it works. Very nice. Okay, so now that we have that, let's actually yeah, let's just do what I was doing there. Wait, what? Let's actually fill this in, right? Okay, so we first convert it to an input, like we first convert it, right? You can delete this comment, it's pretty self-explanatory. We first take the game state and then we convert it into a tensor from the perspective of from the empty row 1, empty row 2. Oh, this is opens up, so this fills all the tensors with all zeros. And then here, yeah, to mark, depending on if the player was in, we just add it. So this is builds the input. Let me just trust that it's correct for now. Get policy and value. So then we have the input here. We have a prediction. Okay, that's good. That's good. And then what do we do? Policy data equals that. I think we can actually kind of copy that here and let's have value data. I'm pretty sure it's going to be the same thing, right? Prediction 1, value data, right? And then value data, so then, okay, so now we know that these are both float 32 arrays. And then this size is, it's an array of 7. This is the policy, this is the raw policy data, right? Let's just call that like policy raw data, and let policy data, just a number array equals to, or what's it called? Array dot, wait, what? Convert to number array. Wait, can I just wait, do I have to do that? Can I just do a number array? Like, can I just call it a number array, see if that does anything? I want to see if this works. Yes, that nonsense again. Okay, so this works. This does work. So we just kind of, so then how do we actually build the policy, right? Okay, first of all, when we're returning, like, we don't know what the policy is right now, but our value data we do know, right? It's a number array, but we know the number array is actually of length 1. See, just like the policy array is length 7, we know that's length 1, so we can just do of 0, and then we know that works. Just say we have a policy here. Okay. Okay. So what is our policy? Like, the policy just means a list of moves, right? So I think that the comments are already there. Here, right? Filter out illegal moves. Okay, well, let's do that. Okay, so we want to filter out illegal moves. Filter out illegal moves. Okay. So logic for filtering out, I feel should actually go inside game state. I feel. What do you think how this applies to BumperCoins? Like, should we have a function that, like, in game state, like game state dot get legal moves, which gives us a list of legal moves that the current player can make? For Connect 4, that can clearly work, but for BumperCoins, how would that work? You actually generate the move. Okay. Hmm. Hmm. Yeah, that's good. So let's see. You have these legal moves. I think I'll just put that into game state. Actually, game state will create a list of all legal moves. Let's actually do that there. So then via game state.ts. So now let's actually get legal moves, and then let's our move array. And let's pretend that like it's like the game status is not like it's still ongoing. Or actually we can do a test right there. Or no, there's no need for that. So get legal moves. So get legal moves is a function that returns a list of legal moves. Okay. Kind of like this, right? Something like that, I think. So then like basically we're looking at the top row, and if the cell is vacant, then okay, let moves. It's a move array equals to new thing. Then let move equals to whatever, and at the end moves dot push, right? Move turn moves. And what is the constructor for move again? Is for P1 and column index. So is for P1 is just the game state, right? Dot game state dot what line 1.1 is P1 turn. And then okay, So this for loop should not be this. It should be like the we want the actual index. Let's call that C. Yeah, something like this. Let's equal to this dot. Just copy that from there. So this dot cells dot zero, what does that give you? This dot cells dot zero gives you the first row of the cells, and you want to like index through that from the column index, or seize the column index, right? And that will give you the actual cell. And then move is that. So if the cell is vacant, that means like you can drop something there, then that's a legal move. Okay, that looks good. So let's copy this. So game state dot get moves. Let legal moves equals to game state dot get legal moves, and then and I have to build a policy, right? Then let legal move prob. I think I have it saved here, right? Oh, oops, I don't. Ah, I can't spell probability. I don't know, probabilities. Move probs. I don't want to spell probabilities. Is a number array equals to just initialize it to there, and then for let move of the legal moves, I can match on the index, right? Match on that against policy data. So for let move of legal moves, we want to get its filter. We want to get its filter. Let the move prob number equals to policy data, and the index is simply the move dot. What's it called? Column index. Column index. Like that, right? So the move probability is there, and then legal move probs. No, wait, what? Legal move dot push move prob. The move and the prob. Okay. Or actually, no. We can call this legal moves with probs. Is like the actual input, right? Whatever, this is fine. And then let actually no, let's do the last thing earlier. Legal moves policy data policy. Let's copy this. Let's copy this type. So we want to push it, right? Okay, let me undo everything. What? No, we need the raw pointers, right? To push something. Okay, so to push something, right? The move and the prob. Well, the prob we know is right here. Move prob. And then the move is just it's just move. Look for the move. We got its prob from the column index, and then we just do that. New policy using the actual thing right there. Okay, so this gives you the policy and the value. This same thing I plan to use both from the client and the server, and I can easily, well, hopefully easily, like do some similar logic, like this is like an abstraction, get policy and value. Like I can hopefully swap it in from game agnostic, like BumperCoins, Connect Four, Chess, anything. Get policy and value. Okay, that was some considerable stuff. So let's make sure everything compiles. Okay, what is this? 143? Oh, is it this? 43 GG? Yes, this dot is P1 turn. Let's think. So then the move is so the move index, like for the player whose turn it is, like let's say this dot is P1 turn is true, right? Then the legal moves are player one's moves because it's player one's turn. If this dot player one's moves is true, then player yeah. Let's look at the yeah. Okay, that looks good. Okay, 2 errors. Fine. That's just import. That is just an import issue. What? Type number? No, that can't be. Oh, right, I see. Because I did a bunch of undos then. So, legal music props. Yeah, okay, that looks good. No, that's not the type. What is this nonsense? Wait, what's wrong? Argument of type move is not assignable to parameter of type move number. Oh, and you wrap this in a paren, right? Let me just look and make sure the signature matches with policy. Like that, right? So we push a new bundle, a move prob bundle, right? Anything wrong with that? No, looks good. Okay, good. So this works. So now that we have our helper function net.ts, let's consume this function. Let's utilize it in bot.ts, right? We just created get policy and value, so now it's time to actually make use of that. So all this stuff can be deleted. That looks much cleaner. Let copy import. I feel like move and policy should be kind of bundled together. We have to actually copy this too, right? The name of the function. We can delete this one then, right? Let policy equals to the net dot this. Wait, what? Sorry about that. To use bins, not the net dot get policy and value. Let me just go back here and look at the commit. Bot.ts. Oh yeah, there's no need for net. We just kind of do it raw. Just raw it. Get policy and value because like we imported the function itself. Get policy and value. So let and policy if that is the zero, like the because that the good returns a pair, right? So that's a policy. Now, what do we want to do for this policy, right? We could like kind of sort it, right? How do you do comparator? JavaScript sort custom comparator. Let me do a JavaScript. Let me just look at sort. I can't believe I don't know this. So this is sorting alphabetically because D is before F, is before J, is before M, H, I, J, K, L, M, you know. Sort compare function, order. It should be a number whose sign indicates relative order. So this is a comparator. First element for comparison will never be undefined. Second element for comparison will never be undefined. If omitted strings. If A is less than B negative, So this is the same as Java, right? -1, 1, 0. Okay. Actually, let me just do a quick I want to do a quick test of this. More tools. What? How do I? Okay. Let's let p1 equals to key1 4, and let's let p2 equals to 7, key2 7, 7. Let pairs equals to oh wait, no, let's do p3. And this can be 8. p3 equals to the key would be let's just make it 3. Let pairs equals to p3, p2, p1. So 8, 7, 4. It's descending. Pairs, right? Is an array of 3. It's 8, 7, 4. We want to sort it to ascending. So now array dot sort, or just pairs dot sort to pass in the what was that? Oh, I just deleted everything, didn't I? Oh no, pairs is still defined here. Let me just do a different tab. Function p1 for a comma b, right? Like that. And then if a return a of 1, which is the value, minus b of 1, like that, right? Boom. Now let's see, like here, 874, 478. Okay, perfect. So that's how you do it. Hmm. Okay. No, what am I doing? Delete this here. Put that there, right? Policy. Policy. Actually, I should put the sort function in the policy itself, right? Let's just sort it. Actually, no. Um, news will be sorted in in most likely in highest probability moves coming first, appearing first. Okay, so it's like the exact reverse sort that we did here, right? Dot sort function p, right? Return instead of like A minus B, 1. We want to do B minus A, right? So return B of 1 minus A of 1. The whole point of this 1 is to, again, extract the number. Okay, yeah, that's perfect. So the sorting is built into the constructor just by convention. Let's write this like by convention. Adopt convention.moves. Policy, and then return policy 0, so we get the first policy, like the first. So the policy is it's a list of all the moves and probabilities. So this is the first move probability, and then that, right? That'll give us that. Is that not correct? And how do we do tie breaks, right? I mean, for now, let's just forget about tie breaks. Let's just forget about tie breaks for now. Some errors. Line 17 seems problematic. We have to actually we have to actually fill it up, right? Game state and the model. Wait, let me see how it's done. Sorry. Oh. So it takes in the game state and the model. Okay, got it. Let's join that. And this dot model. Okay. Let's go second. Six, 7, 2. Channels last. That's good. Let's just refresh that. What's going on? I'm so confused. Just remove everything. This is undefined. Get policy and value. Input. What? I was using this instead of that. Slowly look at the changes here. Data sync. So that looks like a mess. So what is the issue again? I'm so getting annoyed. Getting annoyed. Getting quite annoyed. Okay, let's just quit. Delete that. Get policy and value. This.model.predict input. Open a new tab. Get policy and value, right? So right here, this.model.predict input. This.model. Oh, right. It's just a model. Okay, I see the problem. I see exactly what the problem is. It's a copy and paste issue. Because again, this is net.ts, right? It's not a class. It's just like a utility thing. So there's no need for this.model. We just literally pass it in. Okay, good. Now let's play with the bot. What is my policy? So policy is 0. Policy 0. It's undefined. That's our problem. Oh, we have to moves and probabilities. I see. Okay, fine. Fair enough. Okay. What is an error? That's not. I don't care about that. Okay, so now I'm playing against the bot, and I'm actually using the bot's neural network. Show what the bot won. The bot won. All right. It's doing the same thing. It's only choosing the same thing because some tie break issue. Okay, well, I think that's a good stopping point actually, because like now, what's the last commit message? Get status, get at all, get status, yeah, get log. Almost finished into a URL. So now instead of almost, let's make it finish. Right? Get commit. Oh wait, no. Control A to go to the beginning, right? Okay. Finish integrating into game, right? Status. Get push. Nice. Very nice. Now let's make sure that this shows up. Here we go. Finish running to game. So now our bot.ts class, it no longer like that kind of becomes internal to this function, get policy and value from net. So now what we're doing is like we're getting the policy and the value, and this is crucial. We're passing it the model, which again, recall that the model is like we awaited that. We loaded it up. We load the model up from this, like that's the whole reason we're starting a server, right? Like the whole reason we're starting a server is to actually like go to the server and like serve up the model. Like again, the model, right where the model is right here, right? It's right there. Like we can just do ls the model. It's the model JSON, like the graph specification and the weights. So right here, like this model is like actually like these two files right here, and then put into TensorFlow and then the game state. So this right here, get policy and value, is like the crucial thing. And what we're doing is we're taking the policy that we query from the model via this net, like this net's abstracted, like this crucial function here, which I created, get policy and value from that. Again, like this is just doing model.predict and just parsing it into like a policy class, and then value is just a number. And then we just kind of like all this stuff basically we were putting into net.ts. So all this stuff gets stuffed into this function, and then like it sorts it, and then it instead of randomly choosing it now, like map.random, we're actually like querying this network, and we're actually getting it, extracting it from the policy. So the first zero gives us like the first highest rank move in probability, and then zero to extract not the probability, but we care about the actual move, and that's perfect. Okay, next issue is game state, get legal moves. So what this is doing is it's looping through all the columns where C is a column index, and then it's like looking at the first row, and then it's accessing, like we're basically kind of getting the cells of the first row, but that's what we're doing. And if the cell is empty, that means that we can fill that column up, because if it were not empty, if it were owned by player one or player two, then in the top row is full. That means we cannot add any more, like stuff any more coins there in Connect 4. Like that means that's all kind of jammed up. It's all full. So if it's not, then we add it in. More particularly, it's moved at P1 turn, and then C, the column index. That's just that's the inputs that the move constructor takes. The player one's turn, like again, this refers to game state. This game state, yeah, already talks about that. And then net.ts, import statements, and then all the statements that I cut from the bot, like all these statements here, basically ended up into net. We convert it, which I did last stream. Pretty important stuff like the transposition, TF, like to get channels last, good stuff, good stuff. Then the prediction, like this is the crucial line here, like we're harnessing TensorFlow right here. That's the whole point. We do model.predict. Then some parsing, then some like kind of some data munging, data mashing, just kind of like extracting the policy data, value data. Like I had to like kind of, I remember like looking and like kind of like, I was like kind of like actually like kind of diving into it and like seeing type like 32-bit array or whatever. Like yeah, there's like a float 32-bit array, like number just treats as like I think whatever JavaScript's like by default like 64-bit doubles or whatever. But anyways, the point is that you extract it from the model.predict, then you filter it out, game.get legal moves. I just talked about that. And then we kind of like we're building up the inputs of the policy. Again, like maybe there's no need for a policy class, but I just created one right here because just to like flesh it out. Like instead of like talking in terms of legal moves and probabilities, kind of being more abstract and talking about it in terms of policy. Because again, like Alpha Zero, like when I'm actually doing Monte Carlo tree search, like we definitely care about like returning the policy right here, right? Like PFS is the no, yeah, the okay. So like the point is that like we will be using this policy in like training the network, so it's nice to like, think about in terms of policies. Okay, so then here's policies, just a wrapper around losing probabilities, but it has one additional convention. This neat idea of just sorting it into like highest probability moves appearing first. And this sort function, like we have moves and probabilities, right, in the format of like the move and the number, and we're sorting it in terms of like b of one minus a of one, which is the inverse of this. So if I were to do pairs dot sort bf1 minus af1, right? Bf1 minus af1, then because right now it's like the probability is 4, 7, 8, and then we want the highest probability first. Then we do b minus a, and now we get the same thing there, 8, 7, 4, where key 3, where key is like the move, is 8, so it's like kind of comes first. And that's kind of bf1 minus af1, which is done here, bf1 minus af1. So I think that like so like again like now like the actual bots like they use the they actually extract the move from the policy right here. The policy we get it from this actual model in model.predict, which is like the crucial line, which is right here, model.predict. So now like this what we see here, like we're actually kind of doing that. So yeah, like yeah, I wouldn't let the bot beat me, even though I could have like won here. Why am I kind of justifying to myself that? Why am I like? Why do I feel the need to defend myself against a bot making basically random moves? I don't know, but anyways, yeah. That. So now, like, I guess it's basically done. Uh, it's basically finished. Like we've finished it. Now the game actually uses the network. So all that's left now is to train the network, and that's a pretty big endeavor. And to do that, well, I mean, basically now this whole part is finished, and then the next step is actually the actual MCTS, the Monte Carlo tree search, and that I guess this is a good stopping point. And then next time uh, we'll work on this. We'll treat the neural network as a black box, and then like this is the actual fun stuff. Like this part is pretty crucial to do, and like do in a way that's like kind of game agnostic, so that I mean, doesn't well, I mean, I'll do it first for Connect Four, and then like kind of build it in a way to be game agnostic, hopefully. But that's the idea. Like this is the actual interesting stuff. Where like again, the network gives us a policy, and the neural network gives us like a policy. But then we kind of like explore that. Like we kind of like we take the game state, we kind of play out some games based on, or play out some sequence of moves, and then like we just base that's the whole Monte Carlo research procedure where we kind of take our state, like we make a move, they make a move, we make a move, they make a move, like kind of like similar to like just minimax, alpha, beta, like just like kind of like looking into the future and like considering some trajectories of like state action, state prime, SAS prime, like just kind of like looking into the future, and like by doing that, we're kind of we're refining our evaluations, both in value and policy. Like the Q is kind of our Q score, and then like kind of like the Q score is kind of like the value of S prime, and then like P's are like kind of like, well, the whole idea is that like the more frequently we explore the nodes, like that kind of like gives us the policy. Like yeah, the improved policies similar, like the value at the roots provide a better approximation of a policy. That means like this means that like NFSA is like the edges, right? Like when we do a tree search and like we kind of explore everything out, then like we kind of like see like from the top level, like if we have like the root node and then we have like let's say 7 possible columns that we can drop in, and then like we end up like really visiting column 2 a lot. Like out of all the columns, we really end up using like this edge to like hit to like the second column, then like that state, then like that will probably be the highest the argmax. That would be like the point is that like the amount of times that we visit them, like we use that to like as kind of a proxy for like promising. Like the more times we visit a node, the more promising it is compared to like its siblings like that share the same parent. But I mean, I'll discuss this and like kind of work towards this next time. So yeah, that's it.